All right, so in this video, we're going to go through the Society of Actuaries sample ExamP question number 62. The question reads, a random variable x has a cumulative distribution function, given here, and we need to calculate the variance of x. Right? So, straightforward question, little bit of a trick to it. So, we're asked to calculate the variance, and what do we need in order to do that? Well, you should be familiar with this equation. The variance of x is equal to the expected value of x squared, right? The second moment minus the expected value squared. Second moment minus the first moment squared. So we need to get each of these. We need to get the expected value of x and the expected value of x squared. How do we do that? In order to do that, we need to integrate the PDF. So yes, they gave us the cumulative distribution function. We need to take the derivative and get a function for our, we need to get a density function. So let's look at this. Typically when given a CDF, you might want to just quickly draw a small little graph here, right, of the CDF. So it goes from 0, or the value is 0 until it hits 1. And then the PDF is defined, or so the CDF is defined by this function. So I'll say 1's right there, 2's right there, because after 2, your CDF is 1. So I'm going to say 1 is up here, and from here it continues onward. Plugging in 2 for all of these values, 2 squared minus 2 times 2 plus 2 over 2 should get you 1. So that's that value here. Plugging in 1 for x, you get 1 squared minus 2 times 1 plus 2, which should get you 1/2. Right down there. Okay. And the function between here is, somewhere, something like that. Now, this is something to take special note of. There is a jump between here and here. And when we make our density function, we need to take account of that. All right? So, let's go on and make the density function. So, little f of x is equal to, at specifically x equals 1, we have a value of 1/2. Now, to get the value for in between 1 and 2, we need to integrate the following, differentiate the following. Now, I know the derivative of that is fairly straightforward, but I still find it useful to go through anyway for the purposes of teaching. I'm going to grab an old paper here. Save the planet. Don't call me a hero. Okay, so we have x squared minus 2x plus 2 over 2. To make this a little more straightforward, I'm going to split this up. So it's now 1/2 x squared minus 2 over 2, which is 1x, plus 1. Taking the derivative of this, normal power rule, right? You get x minus 1. So the PDF between 1 and 2 is simply just x minus 1. And because these two are constants, it's 0 just everywhere else, right? 0 like elsewhere or otherwise or something. Just like that. Great, we got our PDF. How do we use it to actually calculate expected values? So let's do that, right? So the expected value of x using our PDF will be the following. It's equal to the value, so 1, multiplied by the actual PDF function, which is 1/2, plus, and then I go through here. because this is a function, I have to integrate between the bounds that I'm given, 1 to 2, of x, this right there, multiplied by the actual function, x minus 1. Okay? And that should be a concept you're super familiar with, getting the expected value of a continuous random variable. Just to kind of show that here, it's the following. The expected value of x, given that x is a continuous random variable, is equal to the integral between, for all of c, whatever the range may be, of x multiplied by the PDF of your function. So that's what I'm doing here. Now, this is going to be 1/2 plus integral from 1 to 2. I mean, honestly, this is just easier to multiply out. X squared minus 1 equal to 1 over 2 plus, opposite of power rule, don't exactly know what it's called. You would get, in parentheses, 1 over 3 x to the third minus, made that mistake, 1 over 2 x to the second. And all of this is evaluated from 1 to 2. Okay? And this is just something to really put into your calculator and solve. So it's going to be 1 over 2. Now again, like I normally say, I don't have these problems done out beforehand because I think it's very useful for you to watch me solve them, right? See my thought process in doing that, and that leads to sometimes just giving me a second to actually compute certain things on my calculator. Over 2. I think benefits outweigh the costs in that case. Oh, okay, nice. Nice round number. 3 over 4. Not a round number, but you know. Sorry, not 3 over 4. 4 over 3. Okay. So now we've got the expected value of x. What else do we need now? The expected value of x squared. And that's going to largely follow the same thing we did here. So expected value of x squared should be equal to the actual value. So for this portion of our function, it's simply 1 squared multiplied by 1/2 plus, integrating again from 1 to 2, the bounds were given, x squared multiplied by x minus 1. And obviously dx. I keep forgetting to put that on there. And multiplying this out, this is going to become 1 over 2. And just like before, this will be easier if I change this to an x to the third minus x squared dx equals 1 over 2 plus 1 over, this should be a 3. Keep small mistakes. Watch out for that. Everyone's susceptible to small mistakes. 1 over 4, x to the fourth, minus 1 over 3, x to the third. And again, that is all evaluated from 1 to 2. And just give me one moment. Yeah, so all this question is really testing you on is, do you know how to go from a CDF to a PDF? And do you know how to get the expected value of a continuous distribution? Right, concepts you should be very familiar with. Oh, okay. So we got 23 over 12 as our answer here. And as stated here, we got an equation for variance, the thing we're actually being asked to calculate, which is e of x squared minus e of x squared, and that's equal to 23 over 12 minus 4 over 3 squared, which then equals try to run away for a second, 5 over 36. And lucky for us, that lines up with one of our answer choices. Okay, so super simple question. I suppose a brief overview would be, we're given a CDF, we're asked to find the variance. I recognize that in order to find the variance, I need the first and second moment. I need to do expected values. How do I calculate expected values for continuous distributions? I need a PDF. And how do I get the PDF? I derive the CDF. And then how do I use the PDF to get expected values? I integrate, right? Using the formula here and here. And once I have that, I can finally calculate variance. So hopefully you can see how I'm moving from one step to another. That's kind of, all math problems, right? Even through grad school, every math problem until your PhD is use a rule, apply a rule, right? Understand a rule, apply a rule. If there are any questions, anything you want me to clarify, leave it down in the comments. I'll answer to the best of my abilities. If you want to see more questions like this, I got a playlist, and I'm adding more to it as fast as I can. And if this video helped you out, hit the like button, because that totally helps me out. Other than that, good luck.